Built by renowned architect Eero Saarinen, the TWA Flight Center opened in 1962, ushering in a new era of air travel. The terminal boasted many firsts, including enclosed passenger jetways, closed-circuit televisions, central public address system, baggage carousels, electromechanical split-flap display, and the satellite clustering of gates away from the main terminal. In 1994, it was designated a New York City landmark and listed on the National Register of Historic Places.
Hello.
Hi. Are you deadheading?
What?
Are you my deadhead to Miami?
Yes. Yeah, I'm your deadhead.
Unable to support the size of modern aircraft, increased passenger traffic, and new security issues, the terminal was closed in 2001 and remained dark until nearly 2 decades later when the combined efforts of the New York Port Authority and hotel owners MCR turned the lights back on. Shortly after the grand opening, we interviewed Joe Gall, senior architect with the firm Beyer Blinder Belle, about the challenges of restoring a national landmark and retrofitting it into JFK Airport's only hotel and convention center.
Where else can you think of in the world where there is a work of monumental architecture, a historic passenger terminal, practically airside, that is repurposed as the lobby for a hotel? Where you're in your hotel rooms, you look outside, right in front of you are the airplanes taxiing and taking off. I don't know how often you have airport hotels quite this close, quite this kind of a scenario. And so that's pretty exciting. The challenges that you might have in a more cookie cutter building are totally different than the challenges that we had in a kind of architectural masterpiece like this. This whole space behind me is basically 4 concrete shells which lean up against each other, and the gap between them are these skylights, and they only touch down at 4 points in these giant piers. So the openness, as exciting as it is and as much of a part of modern architecture as it is, obviously posed construction challenges. When we came and were working on the building in phase 1, some of these large glass panels were starting to slide in their gaskets. Some of them even failed and fell out. So we had to replace the glazing. We couldn't replace them with anything heavier, so we couldn't have thermally improved them in terms of putting in a thicker insulated glazing unit. So we had to stick with 1/4-inch glass. So fine, that's the way they did it back in the 1960s, but how do we reglaze it now? And it turned out that we were able to find the original company that made these zipper gaskets, the Stanlock company. They still have a catalog, and if you ask them, they will still make the same exact gasket for you. Every light of glass was replaced between phase 1 and phase 2. So we've managed to keep the building just as transparent as it ever was. In fact, the curtain wall that we have here, that you can see behind me, it has 7 panes of glass, has 2 air spaces. It is 4¼ inches thick. And each one of those panels, 4-foot by 10-foot panels that you see hung on the building, weighs about as much as a car. The framing all had to be designed so that even the gaps between the glass was not a place for sound to get in. And now when you go into the hotel rooms, you can see a plane right outside the window, and it's like you're in a sound chamber. It's almost a little eerie. The other main design challenge was we didn't want to have any of the new construction visible from the main lobby, which is our highest important interior space on the site. So where do you put the conference center, the event center? The only place that's left is you go below ground where you don't see it. We had to build 2 hotel buildings and a conference center, all of this totally underwater. We were pumping out tens of thousands of gallons of water every minute out of the site just to lower the groundwater enough to be able to hurry up and get in here and build the foundations for these buildings. Above us is the tarmac. The plane is kind of parked right over in this side of the main ballroom that we're in here, sitting on top of these big girders which hold up the roof. These large doors that you see behind me with the rivets and the construction of the doors are designed to be like old hangar doors that slide open. So we were required to have a 2-hour fire separation between the main ballroom and the pre-function space. We tried to do a hangar door that could close on its own and also was tested to have a fire rating. It would be this magical, building element. And we worked very hard on that and came fairly close to it. But in the end, what we found was a much better solution. It gave us much more freedom to design it the way we wanted to design it, make it work the way we wanted to make it work, and make it as big as possible, was to let these sliding hangar doors be just sort of architectural features that have no life safety component to them. And then tucked into a little pocket that's adjacent to the pocket for the hangar doors is a fire shutter, which is an accordion fire shutter. It folds down into a very small size. And when there is an event that's triggered by the fire alarm, this shutter will come out of its pocket and close off and seamlessly make us from 0 rating between these two spaces to a 2-hour rating. The other advantage to accordion product like the Wandoor product is that the accordion product can go around bends. So if you want to come to this event space, you will come from the flight center, the main lobby. You'll walk across what we call the flight tube, which is what used to take you to your gates, to the planes. Now you use it to come to the hotel rooms or to the event center. When you come across that flight tube, you end up in the building a few floors above the event center. So you need to work your way down. And you can take the elevators down, but there's also a grand stair that leads you down, and it connects 3 floors on its way up. That poses its own code challenges because we can have a communicating stair that can connect 2 floors but not 3 floors. So we've come up with a way with a Wandoor shutter at the bottom and the top to kind of subdivide this multi-story stair into 2-story spaces that are code compliant because they have fire separations. Hopefully no one will ever see those shutters. They're really just meant to close in an emergency and everyone gets out. Normally they're stowed away into a pocket. We're up here on the roof. This is where the swimming pool is, and we call it the observation deck, where there's a pool bar. The public is actually welcome to buy tickets to come up here. So you can make a day trip. You don't have to be a hotel guest. You can come up, you can swim in the pool, you can get a meal at the bar, get drinks. This pool was built off-site. It's a series of stainless steel containers. Those stainless steel containers come up and get welded on site. A typical pool can have a lower level of precision because you don't have an infinity edge. So this pool had to be extremely precise. We also have to make sure that we keep sound isolated from the hotel rooms down below. So if there are people who had a late flight and are trying to sleep in the middle of the day, they're not getting noise up here. The project has come together. It's taken a number of years, really a decade and a half, to find a way to make this happen, find a team who could make it happen, and to get it open and get it running and operating. And I know on the architectural and design side, we were really blessed to be part of a great team of designers, of engineers, experts, and contractors. Beyer Blinder Belle, the company that I work for, was the executive architect. The original design, the Lebrano Chiavara architects in Brooklyn, who came up with the design of the whole concept. We have a couple of interior designers. Stonehill and Taylor did the interior design of the hotel, the guest rooms, the corridors, the lobbies. Inc. did the interior design of the event center. On the mechanical side, we had JB&B. They were actually the MEP engineer for the original building, the flight center, when it was built back in the 60s. So it was great to have them back. One Lux was the lighting designer inside the flight center that did some of the very complicated lighting that had to be integrated into the historic scene. They also did a lot of the exterior lighting. Cooley Minato did all of the new construction lighting design. Cerami was our acoustical consultant. They figured out how to keep the noise of the planes out, how to keep the noise of the cogen plant out. We had Waldron engineers designing the cogeneration plant. We had Front as our curtain wall consultant, helping us understand the new curtain wall on the new building. And one last but not least, we worked with the Conservatoire ICR on all of our restoration techniques for the flight center, the outside and the inside. I can't forget to get a shout out to our client, MCR, who made all of this happen, and our contractor, Turner Construction, who did this better and faster than anyone else could have.